Hi everyone, welcome to topic 5. This week we are going to talk about a very important topic, one of the cornerstones of revenue management, forecasting and controlling availability. Revenue management doesn't exist without forecasting and controlling availability. So let's get into it. By the end of this class, you should be able to gain a clear understanding of the formulation of demand forecasting in the context of hotel revenue management, define unconstrained demand and grasp its approximation methods, learn how to measure forecast error accurately, and familiarize yourself with various forecasting techniques and their applications in revenue management. So hotels do many different types of forecasts, okay? And here we have the 4 most important ones. Maybe you are familiar with. So the first one is the demand forecast. This is the topic of today. So demand forecast is done to understand the concept of unconstrained demand, okay? And once we identify the unconstrained demand, then we use demand forecast to decide on price points, right? So if you think about core revenue management processes, we have business analysis. Based on business analysis, we have an overall pricing strategy in place. Then we do demand modeling and forecasting, and based on that we do price and inventory optimization, right? So this is where we decide the price points, and demand forecast is mainly used by revenue department. And demand forecast is done both on a short-term and a medium-term basis. Short-term refers to daily and weekly, medium-term is more monthly and quarterly. Then we have financial forecast. In financial forecast, we are looking at the bigger picture, right? We try to understand future revenues, which revenue department does, but also costs. So when the costs are involved, finance becomes, comes into the picture in terms of users, right? And this is also done both short-term and medium-term basis, but it's not done on a daily basis. Then we have operational forecast, right? Operational forecast is required to complete operational tasks such as scheduling and maintenance. So actually, you can use demand forecast to do operational forecast as well, right? Because when you forecast the occupancy, then based on the forecasted occupancy, you can do your employee scheduling, for example. So operational forecast is mainly used by revenue, finance, and operations, and it is usually done on a short-term basis. Then we have the strategic forecast. So you know that when we say strategy, we are talking about more medium-term to long-term. It is no more short-term. We want to understand the long-term revenue performance, demand implications, and market conditions. So strategic forecast is used by revenue, finance, general manager, and corporate. So again, these are all different types of forecasts, but in the context of this class, our focus is on the demand forecast. So what is demand forecast? It is the act of estimating, calculating, and predicting consumers' demand for products and services in the future. And in the context of hotel revenue management, what do we really forecast? It is usually one of these 2 things, okay? We can forecast arrivals or room nights. Arrivals are guests that are arriving on the forecast day, okay? Not prior to the forecast day for multi-night stays. Just, like today, how many people will arrive to the hotel? That is arrivals. Then we have room nights. Room nights includes guests arriving on the forecast day and prior to the forecast day for multi-night stays. So you are looking at, room nights is more like an occupancy forecast. In terms of level of forecast detail, you can do a forecast very generally, okay? We call this aggregate forecast. And when I say generally, you are just trying to forecast arrivals or room nights as one group. So if today is Friday, how many people will arrive to the hotel on Friday, or what will be the room night forecast for Friday? So this is an aggregate forecast. And When we do forecasting in hotel revenue management, we do it by day of the week, right? Because we have 7 days and every day of the week has a distinctive demand behavior. So we, and similarly, you know, thinking the same way, if we are going to do a forecast for a Monday, we need to look at historical Mondays to understand the demand. Okay, so this day of the week concept is important. Then we can take the aggregate forecast and we can break it down into different levels, right? For example, we can forecast by length of stay. For example, among the people that are arriving today, how many people will stay 1 night, 2 nights, 3 nights, 4 nights, etc. Right? And also we can do a forecast by rate category. So people arriving today, how many of them pay X dollars versus Y dollars, right? And also we can do a room type of forecast. So when people arrive to the hotel today, what type of rooms they have selected, right? So the hotels can do both, right? They can generate a very general forecast and also detailed forecast as well. So now we are going to take a look at this, you know, traditional revenue management forecasting technique. And to understand how we do forecasting, first we need to understand how we look at the data. Okay, so before we consider these 4 blue boxes, let's look at current data, future data versus historical data. Okay, so let's imagine that, let's assume that we are standing today, okay, at current data. Current data is today. From today, we can look at the past, that is historical data. From today, we can look at the future, that is future data. But what does this mean? For example, you can look the day I am recording, this is like August 3rd or 4th, okay? August 3rd or 4th, 2023. It is a Friday I am recording this video. So if I'm looking at historical data and historical demand, I would look at previous year, first week of August, that corresponds to Friday, for example. And I look at how many bookings I have in my hand last year this time. Okay, and so today I am standing at, again, around 3rd, 4th of August of 2023, and it's a Friday. So I look at last year in 2022, I find August, and I find the first week of Friday that corresponds to this date. Okay, and let's say I'm trying to generate a forecast for 10th of August in 2023. So when I look at historical data, I go back to 2022 and I see from this Friday last year, August, first week of August 2002, how many bookings I had in my hand, and then how many bookings I ended up with, how many arrivals I ended up with last year, August 10th, right? Corresponding to 1 week later. So this is looking from current data to historical data, right? When you look at historical data, you want to understand in the past what happened, right? What was the demand at a certain point in time, how many bookings you had in your hand, and then how many arrivals you actually had later on. Okay, so this is the point where we look from today to the historical data. Then from today we can look at future data, right? If we go back to the same example I am looking at in 2023, first week of August. So first week of August corresponds to, and right now as I'm recording this this session, we are in 2023 and we are in August. So today, So I actually just checked the dates. Today is 4th of August. So next Friday, then it is going to be 11th of August, okay, in 2023. So when I look from current data into the future, let's say I'm trying to understand, how many arrivals I might have next Friday, which is 11th of August. I am looking at today. On 4th of August, Friday, how many bookings I have in my hand today for a future date, okay? So this is how we look at like data in two different points in time. So then what are the data points that we look at when we put together a basic forecast? And here I put the title Traditional Revenue Management Forecasting. It's traditional because here we don't use so much the help of information technology and artificial intelligence and machine learning techniques, right? This is traditionally how we do forecasting. So let's start with top right. Booking pace. Booking pace is the speed at which bookings come relative to the arrival date. And if you look at booking pace for FITs are frequent independent travelers, right? Individual travelers versus groups. So this is just very basic way of looking at booking pace, but actually you should look at booking pace per segmentation, right? Per different customer segment. What is their booking pace? What is their booking behavior? Then you should take a look at events that take place in the hotel and in the surrounding market as well. Are there any special events? And among these events, which ones are repetitive, which ones are not repetitive. And also you should always keep an eye on the competitors, historically as well, right? You want to understand their offerings, their price value relationship, and their price positioning within the comp set. Then we need to also look at historically what are the cancellations, denials, regrets, actual room nights sold, no-shows, extended stays, and early departures. So what are these things? Cancellation, this is quite obvious, right? Customer makes a booking, but then they cancel the booking. This affects the forecast, right? So you need to historically collect this data. Denials and regrets, this is a quite important terminology. I'm going to introduce these to you shortly. Historically, you want to know actually how many room nights were sold, right? No-shows are those customers that book but they don't show up on the check-in date. Extended stay are those customers that originally booked for a shorter length of stay, but they would like to extend their stay. Early departure is opposite of extended stay. They completed their booking for maybe 3 days, but they want to check out after 2 days. Okay, so all this historical information should be collected. Then we have group unitization. Group unitization is also called wash percentage. This is about groups. Let's say you have a group booking for 100 rooms, but they only show up with 98 rooms. On the check-in day, 98 rooms check-in out of 100, then wash percentage would be 2%. This is also important to look at historically and try to forecast, right? Because if the wash percentage is high, you need to understand that group behavior, look at the contract terms carefully, and possibly set those rooms aside to sell, right, to your current customers. And DOW trend means days of the week trend. Again, when we look at data historically, we look at it by day, right? You want to understand each day what is the behavior of the demand. And then let's look at the left side of this visual, where we are looking at from current data into the future. Okay, so now we turn our direction completely. We are not looking at the historical data anymore. We are looking for future data. And in future data, we are basically looking at whatever data or information we have on our hand for a future date. Right, so again, this is on top. left hand side, this is very similar to historical data, right? We need to understand the speed at which bookings are coming for different customer segments, especially individual versus group travelers. Then we look at special, repetitive, non-repetitive events, and we always keep an eye on the competition and try to understand how competitors are pricing relative to us. And we also look at their price value proposition and price positioning. Then on the bottom we have lead times. Lead time is sort of, very similar to booking pace, right? When you start discussing a business with a client, right? A contract or group business. So from the time of the discussion, how long it takes actually to close the deal, right? The lead time is important. And again, when we look at future data, what is the average length of stay, right? How does length of stay change for different type of customer segments? What is the overall pricing strategy of the hotel, right? And how are you working internally with your sales team? And also another very important revenue management forecasting terminology is constrained versus unconstrained demand. And just like denials and regrets, I'm going to shortly define this concept as well. And then OTB means on the books. So what is the demand we currently have on the books? Okay, this is also the same thing with ROH, reservations on hand, right? Reservations on hand or reservations on the books refer to how many bookings we have right now for a future date. So all these together, all these data points and information help us to form an effective demand forecast. So on the previous page, I try to illustrate what data points we look at when we develop a traditional revenue management forecast. And one of the important parts that I would like you to understand, how we look at historical versus future data standing from today, right? So I try to explain it to you on the previous page, what with all the numbers and dates, I think it is better if I put it in writing. So here it is. So I'm going to use the same example that I try to explain. Let's say today is Friday, August 4th, 2023, and I want to forecast arrivals for next Friday, which is August 11, 2023. So to do this forecast, I am going to look at data in two different directions, okay? The first one is from today, looking at the future, and the next one is from today to look at historical data. So let's look at the future data first. So when I look at future data, I check how many bookings the hotel has on today, which is Friday, August 4th, 2023, for next Friday. That is Friday, August 11, 2023. So I'm trying to create a forecast for next Friday, right? So I'm just looking at how many bookings I have on my hand today for a future date. Okay, this is how we look at future data. How about when I look at this information as historical data? What do I do? So the date we are looking at today is Friday, August 4th, 2023. The first thing I need to do is to find the equivalent of this date in 2022. Okay, so I look at 2022 calendar and I see that first Friday corresponds to August 5th, 2022. Okay, it's not August 4th. So what we need to remember here is it is not the date that matters, it is the day that matters. Okay, so it is not the date that matters, it is the day that matters. So the day we are looking at is the first Friday of August in 2022. So that corresponds to Friday, August 5th. So I will first check how many bookings the hotel had on that Friday, August 5th, 2022 for Friday, August 12th, 2022. Okay, because we are looking at a 1 week window, right? And if we start with August 5th, next Friday in 2022 will be August 12th. So first I check how many bookings I have on my hand 1 week before arrival last year, right? Next, I am going to check how many arrivals hotel ended up with on Friday, August 12, 2022. So now we have data from looking from today into the past and looking for today into the future. And then how do we use this data? We are going to use some basic forecasting techniques to put future data and historical data together to generate a forecast. And I will teach you how to do that. So let's continue. Now we have to understand some key terms that are essential to understand in revenue management forecasting context, okay? Those are unconstrained demand, denials versus regrets, and booking pace. So the first one is unconstrained demand forecast. Everybody that takes a revenue management class need to know this terminology, okay? And in this example, we are going to look at 1 week of data, Sunday through Saturday. And then we have occupancy data on our x-axis and number of rooms data on our y-axis. So we are looking at a hotel that has 300 rooms. Okay, and occupancy data is divided into two components here, observed demand and unconstrained demand. Observed demand is your occupancy, right? It is already recorded data. And unconstrained demand is the demand to the hotel without any restrictions. Okay, what would be the demand to a hotel without any restrictions? What are the restrictions of a hotel? Number of rooms you have is a restriction, right? Once your hotel is full, then you cannot accommodate more people. Or you may have booking controls, terms and conditions, right? Rate fences that limit people from booking the hotel. Or maybe the price, right? They want to book the hotel, but they are not happy with the price. These are all the restrictions. So unconstrained demand represents the demand to the hotel without any restrictions. In this example, I think interpreting Tuesday and Wednesday is very easy, right? The hotel is 100% booked, but there is still demand to the hotel. So those are the blue sections, right? The demand that is not necessarily observed and recorded, but it exists. But there are also some days like, Sunday, Saturday, Friday, when the occupancy is pretty low, but there is still additional demand that didn't translate into bookings, right? What can those be? They can be, again, the price sensitive customer that doesn't want to book the room. The rates they want is not available. Or maybe type of the room that customer wants to book is sold out, something like that, okay? So the official definition of unconstrained demand is the demand not limited by the hotel's capacity. And constrained versus unconstrained demand. Constrained demand is a demand that is held by or confined by rules, restrictions, and availability. And unconstrained demand is the naturally occurring demand that occurs in the absence of restraints and restrictions. So in revenue management forecasting context, it is important to capture unconstrained demand, right? Because if we know unconstrained demand, then we know the true demand to this hotel. But when it comes to the computation of it, if you ask, can unconstrained demand be computed? It cannot be computed, okay, to 100%. It can be only approximated using mathematical techniques. Why? Because, look at the definition. How can you possibly calculate all the naturally occurring demand to the hotel, right? This includes like all types of customers all around the world that look at your information online, check your rates, check your competitors' rates, change their travel plan for one reason or another. It is very difficult to capture it. But then we also should ask this question: why is it so critical? Why is it so important to capture unconstrained demand? Well, it is very important because if we know the true demand to this hotel, then we can develop a much better pricing strategy, right? Just to give you an example to put this into practice, let's say your hotel is sold out. For whatever reason, and then there is still a lot of demand. There are still customers that are going to your website, that are calling your call centers, and they are trying to book. and they can't. Your hotel is full. If you continue collecting this data, then the following year, your revenue management system is going to alert you and will tell you, don't sell so many rooms in advance, because close to the arrival date, it is very likely that there will be customers, there will be demand, and they will be willing to pay higher rates, right? So it is very important to try to capture unconstrained demand. So the next two terms we are going to review are denials and regrets. Okay, let's start it with regret. Regret is defined as a potential customer who has made an inquiry for a date or dates. Your property was available, but for whatever reason, the person decided not to book your hotel, right? So we call this regret because like hotel regrets losing this customer. Hotel is available, there are rooms, but for some reason, person decides not to book your hotel. So regret can be considered as a price-sensitive customer, right? There is something that drives the customer away from completing that booking. And we also call this non-demand downturn, because if you're available and if your customer chooses not to book, maybe they are not happy with the price. But if they are not happy with the price, are they really your target customers? Do they really represent demand? Right? So if there is demand, but if the customer is not willing to pay your price, and if that is the right price for your hotel, then maybe this person shouldn't be considered part of the demand, right? That's why regrets are also called non-demand downturns. So non-demand downturn occurs when either a requested rate is not offered due to, accommodation booking rule restrictions, or the customer chooses not to purchase after, the room rate was offered to them. So the reasons might be, again, price. Maybe customer is not willing to buy, or it might be the booking rule. The request simply doesn't meet the customer's requirements. Next, we have denials, okay? Denial is considered as a demand downturn. So what does denial mean? A potential customer who has made an inquiry for a date or dates, your property was not available for that person to book, okay? Maybe the requested rate or the room type. So this one, why is it called denial? Because like hotel denies the customer, right? Customer presumably would like to book, but is not able to book. So we also call denials demand downturns. Okay, a demand is taken into account when a customer is willing to pay the price, but the property is unable to accommodate the booking due to a restriction or lack of inventory availability, right? Restriction might be, your hotel is booked to capacity, maybe your hotel is close to arrival, or maybe there are length of stay restrictions. We can actually take this concept of denials and regrets, and we can also implement them to our function space, right? Catering and convention turndowns. So let's look at, what would consider as a part of demand and what would not be considered as a part of demand. For example, if the customer would like to book, but you don't have meeting space available, or you don't have guest room available, or maybe room catering space ratio guidelines don't work for the customer. So what is room catering space ratio guidelines? For hotels that have large function space, usually when they work with a group, they ask the group when the group books the convention meeting space, they have to book it with certain number of rooms. Okay, this is the requirement. But maybe because there are no enough guest rooms available, the client is not able to meet the room catering space ratio guideline, right? So if the customer is going away because of these reasons, then they should be considered part of the demand. But if the group size is too big for the hotel, or if the client has a bad history on credit or materialization, that means, they negotiate, but they never sign the deal, etc., or they cannot pay for the room catering prices, right? Then this is more of a regret. So you wouldn't consider that as part of overall demand. So the next concept we are going to take a look at is the booking pace. Okay, booking pace determines when a contract's individual reservations are likely to be made. And the time when bookings are likely to be made impacts whether they are accepted at a specified rate, because opportunity cost may change in the lead up to the day of arrival. So what does this mean? So booking pace is a very, very important sort of graphical information that revenue people look as per their different customer segments. Okay, in relation to arrival date, you want to understand each segment's booking behavior. How many days or how many weeks in advance do they start booking, right? And how does the speed of these bookings change as you get close to the arrival date? It is very important to understand this, right? Because it impacts pricing strategy, it impacts available inventory left at the hotel, and it also affects the pricing strategy of the hotel. So here is an example of a booking pace. On our x-axis we have days before arrival. So in this example we are going all the way to 83 days. So we are a little bit short of 3-month window here. And then ROH is reservations on hand. So this is the same concept with OTB, on the books, right? Reservations on the books. So this chart represents the number of reservations on hand at different times. And they are the times are charted as days before arrival. Usually we look at always days before arrival, but there is something very interesting here, right? There is day 0 and then day -1. So why is there -1? Day 0 would be the arrival date, and -1 would be the day after arrival. Okay, why do we take DBA -1 into consideration? Because only after the arrival date you know the actual arrival numbers, right? Maybe there are some early departures, maybe there are some cancellations, no-shows, etc. You only understand after the arrival date what the actual arrivals look like. Now we are going to take a look at how forecasting error is computed. So how does a forecasting error occur? So very basically, for example, you forecast tomorrow's occupancy to be 80%, but tomorrow's occupancy ends up being 82%. Then your forecasting error 2%, right? So you are looking at what is the difference between your forecast and the actual. In very basic terms, this is the definition of forecasting error. But there are several statistical methods that we can use to measure this error more precisely. So let's take a look at them. So the 3 errors we are going to look at, and this is also the 3 errors that are used in real world when we look at hotel revenue management forecasting. I shouldn't say 2 measurements, it's 3 measurements: mean absolute deviation, mean absolute percentage error, and mean squared deviation. So forecast error, again, is very basically we are looking at the forecast at time t and subtracting that from actual at time t, right? Mean absolute deviation, it shows you how far off you are on an average in terms of the number of rooms. Okay, mean absolute percentage error. Mean absolute percentage error is the most popular and most widely used measure. It shows how far off you are on average on a percentage basis, and mean squared deviation looks at the average of the squared errors. So you see the easiest one to interpret here is the mean absolute percentage error. So let's look at these 3 error terms through an example. So use the table below, is not below, table on the right to calculate mean absolute deviation, mean absolute percentage error, and mean squared deviation for the forecast data provided. So we have from one Friday to another Friday forecast versus actuals, and we look at the deviation. Okay, so we just do forecast minus actual, right? 92 minus 100 is minus 8, for example. 115 minus 108 is 7, etc. So this is how we calculate the deviation. So how can we calculate mean absolute error or mean absolute deviation? So we take the deviations, right? From all these deviations are from this page. And then we need to calculate absolute value of each deviation. So if you remember a little bit of mathematics, when you take an absolute value of any number, it comes out as positive, okay? So the absolute value of minus 8 is 8, right? Absolute value is 7, it's still 7. So absolute value of any number comes out as positive, okay? So then we take the absolute value of each deviation. So how many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8 numbers. Okay, so we are going to find the mean of the absolute deviation. So how do we do that? You can do that with your calculator right now. You take 8 plus 7 plus 9 plus 2 plus 7 plus 10 plus 5 plus 7, right? And you divide that by 8. Then we get 55 divided by 8, so this is approximately 6.88, right? So this is how we calculate mean absolute error or mean absolute deviation. The next term we are going to take a look at, so this is the most popular way of, calculating error, is mean absolute percentage error. So we again start with the deviations. Deviations are same with the previous page. Then we are going to take the absolute value of each deviation. Yes, we have done that also. And then we take the absolute mean of the deviations. That is the measure from the previous page, right? 6.88. But then the fourth step, we are going to divide mean of the absolute deviations by the average number of actual rooms sold. Okay, so let's go back to our data. So we have our actuals here. So let's do another calculation. So you take 100 plus 108 plus 82 plus 78 plus 95 plus 69 plus 113 plus 120, and we have 8 data points. So when we do this calculation, we get 95.63, and that is average to 96. So 6.88 divided by 96, we get mean absolute percentage error of 7%, right? So what do we see in this calculation? We see as a percentage how much we deviate from the actual arrivals, right? So it is much more easy to interpret mean absolute percentage error. So, and then the last measure we have is mean squared error. So in mean squared error, we take the deviation and we take a square of each deviation, okay? And when we add the squares up and then find the mean by dividing it by 8, we have 8 data points, we get 52.63. So mean squared error or mean squared deviation is 52.63. So now I want to have a short discussion with you about whether you think forecast accuracy should be part of revenue management performance measure or not. Okay, and the idea here, the question really we are asking here is, should we focus on forecast accuracy to the point where it impacts price optimization, right? Because if you think about forecasting in general, it is like a living and breathing thing, right? So as things change in the market, as competitors change their prices, as your customers change their buying behavior, forecasting is going to change, right? So if you make forecast accuracy as a part of revenue management performance measurement, then maybe your revenue team might be too focused, right, on getting the forecast accuracy as good as possible instead of optimizing prices. So this question was asked to me when I was attending a general management conference of an international Asian hotel brand. Okay, they invited me to their GM conference, and I was giving a talk about the importance of revenue management for resort brands. This was a luxury resort brand, and in my session with the corporate, so they were putting together performance measurement for each hotel, right? Then this is their KPI, then they measure and compare all hotels on this particular KPI, and they put together this list of performance measures, and then they asked me what I think, what is my expert opinion. And my expert opinion was that, and it is still the same, forecast accuracy should not be a part of revenue management performance measure. Okay, forecast is a tool to help revenue team to do price optimization. But if you have your revenue team focus too much on forecast accuracy, they might lose the sight with price optimization. Okay, so this is my viewpoint, and actually I have also an expert opinion that is going to, explain his perspective on whether forecast accuracy should be a part of performance measurement or not. Okay, so this presentation is from one of the Duetto founders, Mr. Marco Benvenuti. So let's listen.
I used to say this when I used to work in casinos, that if I could give you a forecast that was even 97% accurate or 100% accurate, I would not be working in revenue management, but I'd be at the tables playing roulette or craps or whatever the case may be, and I could actually forecast what would be the next number that would show up and become a gazillionaire, and then probably get kicked out of the casinos for being too good of a player. And so the same thing happens in revenue management. So in revenue management, you take a little bit of a gamble of a risk because you're dealing with future, you're dealing with a forecast, and there is volatility there. So it's good to accept that forecasting error should be there, should be tolerated, and we should always learn from it. I still see situations where people are like, well, I get my bonus or I get my incentives based on a forecasting error. I need to be, 5% or 10%, 30 days out, whatever the case might be. And the question that I would like to ask the people that actually set that incentive is, if I'm a revenue manager and you give me a target on a forecasting error, I can make the forecasting error happen. Because I am in control of the forecast, first of all. So I can sandbag a forecast, I can pad it, I can do whatever I want, and then I control the price. So of course, if I need to make up forecast, I can lower my pricing and make up the forecast. Or if I'm ahead of pace compared to that forecast, I can just raise my price even more and slow down demand and actually meet the forecast as well. Does that mean that I'm making the most money and I'm optimizing for the right price for the right customer? Not necessarily, because what I'm doing here, I'm actually just trying to fit the demand into a fictional target that I set up probably months ago and I'm bonus against, and so that's the human behavior that I'm going to do. That's why at Duetto with Game Changer, we always try to first understand the behavior of the customer and nail the right price, which is why we do cyclical experimentations into algorithm. That's why we look very closely at web regrets and denials and the conversion on the web. That's why we look very closely at real-time pickup coming from the PMS, so we can really adjust that price, understand how it reacts with the competitors' pricing, who also will look very carefully and multiple times a day, and really try to nail what is the best price that will yield the most amount of money for me, and then adjust the forecast based on that that price and based on what the competitors are pricing. Because we don't live in a perfect world where you are the only hotel there and you adjust your price and you can control demand. You live in a world where, again, you have more than 300 distribution channels and full pricing transparency, and customers do shop on multiple sites. And so your price and your relative price to your competitor does matter quite a bit, and it can change the demand and create swings in your booking curves that are quite significant. The reason why this might be hard to digest, even for people that have been working on the industry for 20, 30 years, is because we've been trained to first think about the perfect forecast that is taken at face value, which should never be taken at face value because the forecast is doomed to change, and then find the perfect price that optimizes that forecast. That's how the industry has been trained. I mean, when I used to be trained on traditional revenue management system that I used, the customer support person always said, do not override the price, override the demand. You put more demand, the price will go up. You put less demand, the price will go down. But who am I to even know what demand is going to be when I don't even know, for example, my conversions and my regrets and analysis on the website? It's always trying to find what is the right price right now for the customer, and it's okay to override price, and actually our application learns from it. And then look at the price of the competitors and what is the interaction and what is the conversion and what is the pickup, and then adjust the forecast based on that. So the forecast is always a byproduct that is constantly changing, should be probabilistic, and should be tied in to whatever pricing strategy you're doing, not vice versa. But it's always rooted into how much money you're taking to the bank. In the end, as I keep saying, okay, I nailed the forecast, great, gold star, doesn't mean that that translates that I'm taking the most money in the bank. We're dealing with a perishable inventory. We're dealing with an ever-changing demand in a very challenging environment where the consumer now has a lot of power and the intermediaries have a lot of power. And so it's not, again, about nailing your forecast 60 days out, 90 days out, and making it whatever you want it to make. It's about capturing in real time as much money and as much value as you can.
So I think this was quite a good way to explain why optimizing price is more important than forecast accuracy, right? And if you are interested, Duetto is a company that provides a revenue management system. Okay, we are going to talk about Duetto and Ideas. Ideas is another company that has revenue management systems. These two are the most popular revenue management system providers in the hotel industry right now. So I think there is enough evidence with my explanation and with Marco's explanation to show that forecasting accuracy and forecasting itself is just a tool, right, to do price optimization. So you shouldn't put a forecast accuracy target as a KPI for your revenue management team. Now we are going to take a look at revenue management forecasting methods. Okay, we are not going to go into these methods, all of them very much in detail, but I would like to give you like an overview of how forecasting methodology looks like. Okay, most probably you are not going to do the forecast yourself, but you should still understand what forecasting methodologies exist, okay, and how they are used. So we are going to look at historical methods, advanced booking methods, and combined methods. Historical method is, mostly using historical data, okay, for analysis. And we have different methods. We can look at same day last year, moving average, exponential smoothing, or other time series methodologies like ARIMA. ARIMA is autoregressive integrated moving average. So here, really moving average and exponential smoothing are the most popular methods. Then in advanced booking, we are looking at advanced booking, right? Bookings into the future. So instead of looking at historically, we are looking at the future data. and there we have additive and multiplicative models, and also other time series models. And when we say time series, it means our data set goes over time, right? This is called time series. And then we have combined methods, where historical methods are combined with advanced booking methods to generate a forecast. So for that, we have weighted average of historical and advanced booking forecast, regression models, or full information models. And something that is not included traditionally in forecasting methodology is machine learning models. I'm not an expert in machine learning models myself, but I just want to provide you with an overview, because when you look at the sophisticated revenue management systems today, they all start using AI and machine learning models. So now we are going to look at the most popular historical models, moving average and exponential smoothing. Let's look at moving average first. So we are going to look at historical observations, okay? XSS is for the period up to present time t. And then we are trying to generate a forecast for ft plus 1, right? Present time is t, so t plus 1 is the time where we are trying to create a forecast. In its simplest form of extrapolation forecast, we are basically looking at M period moving average. Okay, moving average is very simple forecasting method. We are basically looking at arithmetic mean of the M most recent observations. And most recent observation range is usually between 2 and 15 periods. Okay, and we have the formula here. We have AS as the actual observation, room sold for the period S, and the forecast made in the period T is for period T plus 1 is. So we have the formula here, but I mean, for many people, formulas are confusing and they don't necessarily want to read the formula. When we take a look at the example, you are going to see it's very simple. So in this table, we have period, so this is T, it starts from 1 to 13. Then we have actual demand, that is AT, right? Then it becomes like historical information. Then we have moving average when M equals 2, so we are going to use 2 periods for M equals 2, and then we have moving average M equals 5. There we are going to use 5 periods. So when M equals 2, we take period 1, period 2, and we take average. So 100 plus 120 divided by 2, you see moving average at the third period is 110. Then let's move on to the next one. In period 4, to calculate 133, we will get 120 plus 146 divided by 2. Okay, so we are literally moving the averages. So this is when we use M as 2. So let's take a look at M at 5 periods. So to calculate moving average, this time we are going to take first 5 periods. So first 5 periods are 100, 120, 146, 184, and we take an average of those, then we get moving average of 110. So to get 111, we start from 120, 146, 184, 104, and we take an average of them. That should give us 111. So this is the idea, okay, of moving average. So how does moving average looks like in a graphical representation? So we have the periods versus demand. So if you look at the black line, right? The black line is the actual data, and you can see moving average with M2 and M5. You see M2 is somewhat similar to the actual, right? But when you look at M5, you see it is much more smoothed out, right? So throughout moving average and also exponential smoothing methodologies, we are able to see the historical trend. Okay, you don't see so much about these, sharp ups and downs, because you are smoothing the data by taking averages. So the next methodology we are going to take a look at here is called exponential smoothing. So exponential smoothing in its essence is very similar to moving average, but in moving average we use equal weights on past m observations, right? For example, when we take two periods, we just take an average of two, so they have equal weight. But for exponential smoothing, we don't use equal weights, okay? So then forecast for ft plus 1 as a weighted average between the most recent observation AT and the previous forecast, and instead of a equal weight, we use a weighted average, and weighted average here is the alpha, and alpha is the smoothing parameter, okay? And smoothing parameter should be between 0 and 1, 0 and 1 being inclusive. So here is the formula to calculate the forecast for t plus 1 periods. We need to take the smoothing parameter and multiply it with the actual, okay, most recent observation, plus 1 minus alpha, the smoothing parameter, multiplied by previous forecast ft. So here's an example. So we are going to take a look at two exponential smoothing like alphas. We have alpha equals 0.2 and alpha equals 0.8, right? 0.2 is actually a low type of alpha because the range is between 0 and 1, and 0.8 is very high, right? So what do we do? So we have the actual demand starting from period 1 to period 14 in this example, and then we have the forecast. So we take the if we look back at the formula, we take the actual and we multiply it with the smoothing parameter. So we start from so what we do with the exponential smoothing, the actual first 100, we put it as the second value for exponential smoothing, okay? So this one here, 100, comes over here to exponential smoothing side. And then we take the actual, second actual, which is 120, multiply it with the smoothing parameter, plus we take the forecast at time t and multiply it with 1 minus alpha, that is 0.8. And then we get our forecast as 104. And for this line here, we take our actual t at time t, we have 146 multiplied by smoothing parameter of 0.2 plus 104 multiplied by 0.8, right? We get 112.4. So this is how we compute exponential smoothing. And the calculation for 0.8 is also the same as 0.2, just that smoothing parameter is much higher. So how does exponential smoothing forecast look like? So we have the actual here with the black line. You see when the forecast is 0.2, the blue line looks much more smooth, right, in comparison to alpha of dotted line of alpha 0.8. The fluctuations are quite similar to the actual data, but with the smoothing parameter of 0.2, we see it is much more smoother. So very similar to moving average, we are able to see the historical trends here, right, without these up and downs. We are basically smoothing the data by using these smoothing parameters. So these were the two examples where we use purely historical data. So now let's take a look at advanced booking models, and we are going to look at additive versus multiplicative models here. And the additive model assumption is reservations on hand for a future date is independent of the final number of rooms sold. This is the assumption of the modeling. And multiplicative model assumption assumes that future bookings are proportional to current bookings. So let's take a look at an additive model example, and the most popular example is used in the context of short-term forecasting in hotel revenue management, okay? We introduced the concept of pickup before, so here is the official definition. Number of reservations picked up from a given point in time to a different point of time over the booking process. So in this example, we have reservation date, reservations on hand for 5 days in July and August. Okay, so those are 15th of July, 22nd of July, 29th of July, 5th of August, and 12th of August. We also have reservations on hand values and pickup values 4 weeks in advance, 3 weeks in advance, 2 weeks in advance, and 1 week in advance, right? Corresponding to 28, 21, 14, and 7 days. And also we have -1. Remember, -1 is the day after arrival. So how do we calculate pickup? So we have on average 110 actual arrivals. Okay, here this is calculated for us, but approximately 4 weeks before arrival, on average we have 15 bookings in our hand, right? Yet we end up with 110 actual arrivals. So 110 minus 15, our pickup is 95. 3 weeks before arrival, on average we have 30 reservations on hand. We end up with 110 actual arrivals. 110 minus 30, our pickup 3 weeks before arrival is 80. And when we do the same calculation for 2 weeks or 1 week before arrival, we see the pickup is 70 and 40. And then how can we calculate the forecast? Okay, so forecast is going to be a function of two things. Okay, we are going to look at the historical data from today and also future data from today. So the formula is reservations on hand we have now for a future date plus expected pickup by looking at historical data. So the question is, you currently have 20 reservations on hand for a date 2 weeks from now. You are wondering how many more reservations you might expect to receive. Assume the dates covered in the table are relevant to this day or date. What is your forecast? So we are looking at 2 weeks before arrival. So 2 weeks before arrival, our pickup is 70. Okay, so our reservations on hand right now is 20 and we expect to pick up 70 more bookings within 2 weeks. Then our forecast for the date 14 days from now is 90. Okay, so here in this example you see we combine, right? We combine reservations on hand data into the future versus historical data. Using the historical data we calculated expected pickup. So this is one very easy way of doing short-term forecast through the use of pickup in hotel revenue management. And now let's take a look at computation of average remaining demand and average booking rate. This one is very very straightforward. So and it is called advanced booking model. So we have days to arrival starting from 364 days, and then we start again from 543,210. So 364 days before arrival we have all 300 rooms to sell, okay, and there are no bookings. But as we get closer to the arrival date, for example 5 days before arrival, we have 180 bookings on the books, right? Reservations on hand is 180, and average final demand is 300, right? 300 is the number of rooms in this hotel. And then what is the average remaining demand? 300 minus 180 is 120. So then what is the average booking rate at this point? We have accumulated 180 bookings out of 300 bookings possible, so average booking rate is 60%. So as more and more days pass, for example we come to 2 days before arrival. 2 days before arrival, accumulated bookings is 220. So 220 represents 73% average booking rate, right? Because total number of rooms is 300, 220. You have accumulated bookings, so you get an average booking rate 73%. So again, this is quite, straightforward to understand. Then we have the multiplicative model. Okay, multiplicative model, to create a forecast, we look at reservations on the books divided by average booking rate. So we have the stay date and forecasting dates, and you see we are basically looking at 5-day window, 5 days before arrival, and we record bookings on hand. So this is reservations on hand, or OTB, on the books. So in this example, we have, for example, 1 day before arrival, 270 bookings on hand. So here we have two different types of forecast, okay? Additive forecast and multiplicative forecast. So we are looking at 1 day before arrival here. So on the previous slide, you see average remaining demand 1 day before arrival is 50, right? So to calculate additive forecast, we take 270 and add 50 remaining demand from the previous page, and we get additive forecast 320. And multiplicative forecast. So again, 1 day before arrival, we have 270 bookings on hand. And from the previous page, we see 1 day before arrival, usually we have 83% of the bookings on hand, right? So we use that 83% as the percentage of bookings. So if 270 represents 83%, what represents 100%, right? So to do this calculation, we get 270 and divide it by 0.83. So using multiplicative forecast here, our forecast is 324. So you see here, for the rest of the days, for day 2, you have actually same forecast using additive forecast and multiplicative forecast, but for all other days, you see the forecast produced by additive versus multiplicative forecast has different results, right? So this is the case with forecasting. Forecasting is very much reliant on the underlying data set, right? And different forecasting methodology you are going to use will produce different results. It is in the hotel's best interest to use the methodology that minimizes the forecast error. That is the most important thing at the end of the day. And then we have more sophisticated methods of forecast, and majority of the forecasting algorithms embedded in sophisticated revenue management systems like IDEAS, like Duetto, they rely on linear regression. Okay, linear regression is basically trying to establish a linear relationship, right, between the dependent and independent variable. Our independent variable is going to be the arrivals, right? We are trying to forecast arrivals. That's the dependent Y variable. And our independent variables will be all the variables we are going to input into the regression model to estimate the dependent variable, that is the arrivals. And then there are combined models, okay? So combined models blend predictions produced by different forecasting methods to develop a final forecast. And for combined methods, there is no optimal mathematical solution, okay? The result, again, depends on the underlying data set. And when you do a weighted average of different forecasts, you need to do the weighing between 0 and 1, depending on how much importance you would like to give to what type of forecast, right? And the purpose here is to determine the weight combination that minimizes the forecast error. Through all these methods, you have only one purpose: to minimize the forecast error. And then the fourth method I have said today that revenue management systems, revenue management algorithms use is through machine learning and neural networks. So this is not my area of expertise at all, but I would like to mention it because this is going to be the future of revenue management forecasting. So when we think about all the forecasting methods that we have talked so far, they all have functional assumptions, okay? And those assumptions may not be in line with reality or not. But the good part of machine learning models, there are no assumptions, okay? No assumptions need to make prior to the analysis. And the system is going to look at interactions in a network processing architecture to automatically identify the underlying function that best describes the demand process. Okay, and while it is doing this, it is going to mimic the way human brain learns from experience. So certainly very, very sophisticated. And there are different levels to it. Okay, there is an input layer, hidden layer, and an output layer. And the idea is training the neural network, okay, through learning the weights of the neurons. And again, I'm going to leave it here because this is not a methodology that I understand myself extensively. And then there are other forecasting methods. For example, Delphi method. Delphi method became very popular during COVID-19 because historical data was not useful anymore and you had to rely on analyst and managers' perspectives. Okay, so what is Delphi method? Formal procedure for extracting analyst and manager's opinion on expected demand. Used primarily when no historical information or when there is an unexpected demand shock or when revenue management is done manually. This exactly describes what happened in COVID, right? The historical data is no more reliable. Nobody knows what is going to happen in different parts of the world. So this is when the Delphi methodology was used extensively in revenue management forecasting context. And then we have fuzzy logic and expert system type of forecasting method, and these try to replicate the rules used by human analysis when monitoring and overriding a revenue management system. So this concludes our discussion of forecasting and controlling availability. I hope now you have a basic idea in terms of how forecasting is done in hotel revenue management context. This is not an easy topic, okay? If necessary, feel free to go over the lecture notes or lecture videos a couple of times.